another one to actually directly speak. So if you could be so kind to just hit the one with the raising hand, so you get actually added into the queue. The other one will send audio directly, which will goof up the audio stream a little bit. Okay, we are actually at the top of the hour. Should we start, Victor? AC, you're sending audio now, huh? That's the plan?
I was going to say good morning before you started, but you guys didn't accept it, so I'll say it now.
It didn't pop up. The thing is, it's a bit slow.
Okay, okay.
It's one of those things. Okay, I'm gonna. If you can disconnect. Revoke.
Yeah.
Voila. Okay, so welcome everybody. So we have 50 minutes time to go over the link state vector, working group here. Let's try. So we have a busy agenda, and I'm going to be trying to keep ourselves, to the planned agenda what we have here. Huh? Let me see if I can advance the slides. So we did a little bit of homework. So we managed to find a scrap, which is going to be ourselves. For the minutes, Jacob Oker was volunteering to take the minutes, so that's pretty well, appreciated. Also, thank you for that. For the rest, we have the note well. You probably have seen this already in some of the other sessions if you have followed it. If not, give it a look. Anything you say is recorded and and falls under the note well of the IETF. From the agenda perspective, so this is the agenda we have. It's a little bit shorter than what we classically have at the face-to-face meetings. So first, we're going to be looking to your agenda, see if everything is okay for everybody as such. Next, we're going to see a quick update on the two key working group drafts here on the applicability and on the BGP SPF itself. And then we will get an update also on the implementation of our LSVR technology here, which will be presented by Keyur. And that will be followed by updates on the set of drafts regarding the L3DL technology itself. So we actually have some good enhancements and advancements there also, and Randy will be giving a short update on those as such also. Now, before we jump into the different updates of the different working group documents and other documents, let's have a look into where we are. So we haven't really met for quite a long time. Now, that doesn't mean nothing actually, has progressed. That nothing actually, has not been progressing within the working group itself. So we did like 2 working group last calls on 2 documents. We closed them, and those documents were pushed towards the IESG for further, handling as such. I spoke before this call with the area director, and they are actually on his plate to process as quickly as time allows, because he's relatively busy with a few other, documents also. In addition, we have done a working group last call also on the L3DL draft. A good set of feedback came from the working group last call, and it is being reworked by Randy and the team. And I suspect he's going to give an update on where we are right now, later on, in the working group session here. In addition, we did do a working group adoption call on 2 other documents with respect to the signing of the L3DL technology and about the upper layer protocol configuration. And if you develop like any type of new technology, then security is a very integral component out of it. You cannot really develop like a new protocol or technology without thinking about those. So these will be very crucial, to progress the L3DL, base spec itself also, because I consider them as one. Otherwise it will never get into the IETF last call itself or get adopted. And then something else, what is on the progress agenda, that is, if you look into, where we are right now, if you look into our charter, then we actually are like, pretty well advanced in, some of the key milestones. We're a little bit late, which is a bit sad. The Yang document itself is still mission in action, but from what I saw in the IDR working group is that the BGP Yang is now going through the last steps of the process. And I suspect, because BGP SPF is very closely related to that, that the Yang model for BGP SPF is going to be progressing, kind of along line with that. But I'm pretty sure that Kiyur will give a little bit more updates on that from that perspective. Now, looking into the fact that we have some key milestones nearly delivered, we need to look into what we're going to be doing with our working group in the future. And some of the new things, we may be looking into, because some of the LD3L documents, for example, are, on the edge of what we are chartered for. So, it does take, so at the IETF 109, between now and then, we will start some discussions on the working group email list on how to do the recharter and what we should be, refocusing upon. So that from the LSVR working group status update. And any questions or any further comments? Because if not, then I plan to progress with the first presentation. Okay, a comment, Kayur, or you have something else to say? Or hello? Did the audio fall away?
I don't hear Kier. Can you hear me?
I can hear you now, yes.
Yeah, I allowed him to speak, but I guess it kept falling off.
I hear Victor, I hear Gunther.
Okay. Kayur, can you speak now?
Hi, can you hear me?
Yes, faintly, but we can hear you.
Voila, it's working. I just wanted to have a quick comment on the Yang model draft that has been worked upon. Basically, the base BGP LS draft for the Yang model has been missing. So we are trying to come up with a common model draft that can be applicable to BGP LS as well as Yang, as well as LSVR. And I think the first version of the draft should be up and running fairly and be submitted to IETF fairly soon.
Okay, perfect. Thank you for the update. Okay, you ready to go into the first set here?
Sure. So I'm going to give a quick update on applicability and the BGP SPF draft. This is the update on the applicability draft. Next slide, please. So version 5 was submitted on the 24th March. We have an update to the version 5, which is going to be version 6 soon. The draft was submitted to IESG. That was the version 5 of the draft. We received a few comments from Boris, incorporated all the comments in version 6. And Boris has been pretty active on the email thread giving us the feedback. Next slide, please. Following are the updates which are going to be posted in version 6. We've added more text to cite examples in section 611 of the draft. Section 62 is again augmented to give an example that talks about constraint peering model between spine and leaves. There is added text now to what it means to have a prefix aggregation, and augmented section 653 to cover all sorts of devices in addition to the controller text that we had in the version 5 of the draft. So those were the changes. We're going to submit version 6 soon, and hopefully we can wrap the draft soon. Any questions?
Nope. Nobody? I see AC in the queue. Ah, okay.
Hey, I just wanted to say that this is AC Lindum, Cisco Systems, that I did submit version 6 when the window opened up this week. So it is in the IETF data tracker repository.
Yes, I saw that. Thank you.
Thank you.
Anybody else? Okay, I'm gonna go to the second slot. Voila. Okay, it's for you again.
Super. So now I'm going to give an quick update on LSVR BGP SPF extensions, the base draft that we have been talking about. Next slide, please. Right. So version 9, again, the last call has been successfully done. Version 9 was submitted in May, which was pretty recent. We now have multiple implementations since the last IETF. We now have an added implementation from FRR, which is an open source implementation. The early review of routing directorate was done. All the comments were addressed way earlier. However, the status for the routing directorate comments being addressed needs to be updated. I am assuming someone will help me out with that, knowing all the comments were taken care of.
Yes, so from the document Shepherd perspective, so I put this particular fact actually in the Shepherd document also, so it's in there, so it's taken care of.
Super, thank you. And I think I only have one slide on this. Yep, and we've gotten a lots of feedback from Chaitanya from AT&T, and as a result of that, we have added him as a contributor. Like I said earlier, the Yang model work is in progress. It's going to be a common draft for BGP LS and BGP SPF, knowing that the prefix encoding and the attribute encodings are exactly the same. The BGP SPF draft has added TLVs, which would be presented in the same draft. We'll try and come up with one unified draft and then look towards IDR and LSVR's guidance to see if we want to split the draft or drafts into multiple drafts, or we can carry on with single draft. That's all I have. Questions?
Nobody? Eerie silence. Okay, then we have about 20 minutes for the next piece of work. Okay, it's you again.
All right. I am now going to talk about the implementation draft for BGP SPF. We have, like I said, two implementations available. Next slide, please. We have an implementation in ArcOS fully available as an underlay. It now works as an underlay for all the overlay SAFIs, namely, interestingly, one EVPN, and we have a implementation for FRR's routing stack. You can see the authors who implemented or the implementers who have implemented this implementations or respective implementations in different OSs. Next slide, please. So this slide talks about what kind of peering models are supported within the two implementations. There is enough flexibility in terms of supporting peering models. Both eBGP and iBGP peering sessions have been supported and been cross-verified. Interoperability looks just fine. Um, uh, the peering models were tested as a single hop peering as well as directly connected on the connected nodes. Uh, Also keeping route reflectors in mind, pretty straightforward. No changes here. The way it was tested was the new SAFI should come up pretty easily and start exchanging the BGP messages as it comes up, all tested and verified. Next slide, please. Then we started on testing what does the messaging actually looks like on a send receive side. Can you send a write update, parse the update on the receive side? Can you create an update and verify the update that you're about to send holds up? The interoperability on both update generation side as well as update processing or receiving of the updates on the new SAFI over and above other BGP messages, including the heartbeat messages and notification messages, were tested, fully interoperable. Even for the notifications that we ended up creating by inducing errors were tested and made sure that they were interoperable as well. So from the messaging perspective and update generation perspective, and update receiving perspective, everything had been tested, and full interoperability is ensured between two implementations. Next slide, please. That, by the way, generation and processing of the updates also covered the attribute processing of the updates as well. And finally, the modifications that were tested were comparing the route selection process, which is very local to the implementation. The phase one NLRI selection, dual stack support, and SPF calculations were done, and the routes that were installed in RIB and FIB were tested. The FRR implementation implements a route reflector functionality, and as a result of that, as it was a out-of-band route reflector, the SPF calculation was skipped in there, and it was simply announcing routes that it was receiving, in some sense reflecting, in this case, what it was receiving. And RCOS was running on switches and routers, and it was simply executing SPF and was tested to make sure that the interoperability is in place. So in this particular section, FRR skipped any updates and any SPF calculations, while RCOS did all the SPF calculations to ensure the right set of fibs were computed on leaf spine switches. All in all, fully interoperable stacks between two different implementations, holding up pretty well. And I think that's my last slide. Any questions?
Go ahead. Looks like Alvaro was.
Hey, yes, Alvaro Retana, Routing AD. Thanks for this, Kair. Can I ask you to please add something about implementations to the draft? Look at RFC 7942. So all I'm looking for is just a short description of the implementations, so that when we go through the AESG, they can see that there are multiple implementations out there.
Alvaro, we have
Yep.
a separate implementation draft already submitted. You're asking me to add a section on top of it, as I understand.
Oh, I see the implementation report draft now. Okay, yeah. So maybe this is then a question to the chairs. So yes, I'm asking you to add a short section, again, 7942. Basically, what it asks for is saying, yes, we have an RCOS implementation version, whatever, and maybe with a link or a pointer to the implementation report, which is what I'm assuming the same content as what you just presented, right?
Yes.
So Alvaro, it's Gunther speaking here, Chair. So also in the Shepherd write-up, actually, I made already note about the implementations out there, but that write-up was done before the implementation document actually was available. So this actually is more like a further follow-up. So we can do like a few things here. Is either we do it in a similar way for future purposes, like what IDR is doing. Have it on a wiki and put like implementation information there. But I think because probably this is actually like kind of a new technology, and from that perspective, additional context and information from what is in the separate document, like what Kiryur now created, is at this point in time probably more useful. I guess I think going forward we probably need to have like a wiki and so onwards for tracking new capabilities and new functionality we will implement or add to the technology.
Right. So there's a two-part, right? The one which is what I think I'm asking for, which I want as much visibility to the fact that there are implementations. So it's great that the Shepherd report says that. Again, just a couple of paragraphs in the main drafts would be great as well, so that no one actually misses that. No one from the ASG looking at the implementations or anything. And then the other thing, which I'm not sure if about the implementation report document. I'm assuming the intent is to have this documented as a draft, not published as an RFC. True?
Me as a chair, I would see this more as indeed as an informational document, which is relevant as long as the two other documents are going through the process. Correct.
Okay.
Now, I do have a question for you also is like, do we put like implementation information and those details in like other standardization or standard, documents itself? I thought
Yes.
it was always like separate.
No. So that's what I'm, that's RC 7942. So basically what that RC talks about is an implementation status section, which doesn't have all the details of I tested this packet and I tested that other packet and things like that. But it is basically a paragraph that says, yes, Arcus has an implementation. It's in this version of the code. And here's a contact person. So just to raise more visibility to the fact that there are implementations. So it's not, an in-depth implementation report or interoperability or anything like that. It's just just raising the visibility so that people know that there are implementations out there.
Okay, makes sense.
So take a look at it's just, as I said, a couple of paragraphs, nothing too in depth, but it provides other people that are going to be reviewing this, because as you said, this is a new thing. The visibility to the fact that there are implementations out there and that we're not just pushing papers around.
Cool, thank you.
I think AC was in the queue. So I'm gonna turn him on. Go, AC.
There's one. If is AC still going to? Is AC still wanting to make a comment?
He queued up a couple times, but it doesn't sound like he's saying anything. So
okay. So one quick comment I have for chairs as well as the participants is, as part of doing an interop, we have also done some performance and convergence tests, and we have interesting results across different protocols. We didn't bring it forward, knowing that it would be a little bit of an implementation specific details, and we didn't know how best to compare and contrast against different protocols. But we have some interesting analysis and if folks are interested, we could always chat offline about that as well. But since there is no standard way of comparing even between different protocols that implements Dijkstra, it's sort of hard to compare and contrast even within a same flavor of implementation as to how the protocol stands and compares against different other protocols. So I wanted to just bring that out there. We will obviously not be covering in the implementation draft, but we have also done that additional level of analysis.
Okay, I think there's a couple people in the queue. Jacob's next, I guess we'll try him. Oh, there he is.
Can you hear me okay?
Yes.
All right, this is Jacob from Oracle Cloud Infrastructure. Kior, I wonder if I can get in touch with you offline about some testing on the implementation that you've got running.
Absolutely, would love to.
All right, I'll reach out to you offline then.
Sure, thank you.
Okay, we'll try AC again. See if it works. Go ahead, AC. Oh, keeps dropping. Not sure what's going on there. Oh, there he is.
I just manually forced myself in this time. Can you hear me now?
Yes.
Yes.
Okay. What I was saying, I think we were talking at the same time. I said I've done something like this for the OSPF v3 extended LSAs. I put a little implementation section. We also had a separate draft. Now I know the Alvaro and others have pushed back on the implementation reports as published drafts, but I think since this is, like you said, is this a new technology, and if we're willing to do the work as a working group, I think we should publish that as informational as well. We can take this up offline with Alvaro and outside the meeting. But I would be interested. I'd also be interested in the performance data that Kayer alluded to. That's it.
Thank you, AC.
No, we have one other comment in one other person in the queue here. Anurag, you're live.
Hello, can you hear me?
Yes.
Yeah, hi. This is Anurag from Siena. I was looking at the draft, and there were a couple of sections in there about dampening of SPF calculation based on existing RFC. Is that to allow for you can say better scalability?
I guess that's a question to
Okay.
Keyur and someone else.
Question to Keyur. Yeah.
Yep. From an implementation standpoint, and AC can add more to that, but from implementation standpoint, we wanted to pace SPF calculations just in case if we were receiving a lot of updates coming in, and how do you sort of just dampen it enough to get enough churn in before we start calculating SPF, and the text was in context of that.
Okay.
AC?
And like,
Do you want to add anything about that over and about to what I say?
Here, I'll let AC back in. I think he has a comment on that.
and just in continuation of the draft, there are 3 phases of decision process as part of the SPF and installation, which has been described. I was just curious now because this is my first time looking at this. This is like we are going towards a stateful implementation. We'll have to keep database for the link states and everything. Is that true as per the implementation of this draft going forward? Because for running Dijkstra?
That is correct. At least the implementations we We have implemented SPF in, has absolutely a stateful behavior. More importantly, all the three phases are somewhat blurred, and this is going to be an implementation specific detail. Different implementations are allowed to do it in a different way. They have a flexibility to do it, but essentially the three default phases that were there inside BGP were pretty much replaced with SPF computation and installing routes in the RIB. Now, how you go about doing that pretty much is going to be very implementation specific, but it's going to be somewhat stateful, for sure stateful.
Thank you, Kair. And just one last one. In this context now, we are looking at the local RIB, or we are looking at starting to splitting the phases in adjacency in and local RIB versus adjacency out.
That is very, very implementation specific detail, Anurag. You are more than welcome from an implementation standpoint
Okay.
to keep a separate edge rib in and maybe edge rib out with the local rib, or you can squeeze that down if you are looking to save some memory and keep a state common. Very implementation specific detail, but the draft allows, more importantly, a flexibility to implementers to implement in whatever way they would like. Yeah.
What would the draft recommendation would be in this scenario?
The draft will probably not make any recommendation and be in
Okay.
line to what the base RFC is, in sense that the base RFC gives you the base BGP RFC 4271 tells you about this three different databases, but actually doesn't make any implementation recommendation. And as you probably very well know, different vendors have implemented it in a manner that has all three different databases kept separate, or some of them have clubbed into a single database. Yeah.
Okay. Thank you, Kair. Maybe
So-
I'll chat with you offline as well.
Absolutely.
Yeah, so I'm just gonna comment. Say, C. Lindum. I'm just gonna comment on the SPF backoff. You know, all the existing IGPs that run SPFs have backoff configuration. Now you can go anywhere to something pretty conservative. And in the routing working group, we actually have a draft that recommends a backoff algorithm. It's RFC 8405 for the minutes. Now, so you can go anything to something very conservative where you only, do an SPF every few seconds, to completely disabling it and doing your SPF whenever you have one pending, and in your internal scheduling you don't have any higher priority work to do. So you're eventually, if you got especially with something, modern processors, and if you know how to do it right, you can do this SPFs for a pretty big domain, especially something simple like we've done with BGP SPF, where you don't have you only have point-to-point links. You can do it in, single-digit milliseconds for a pretty big underlay. And I guess I should say we should have some kind of like over and out when you're done talking.
That would be handy indeed.
And 4.
Or button, my audio doesn't work.
I don't think there's anyone else in the queue.
Okay, then I guess it's time for Randy to speak about the 3-layer L3DL drafts.
Gunther,
Yes.
I will end the presentation by saying that we have a separate implementation draft submitted. We will work with chairs to see, do we want to keep that draft around, or do we want to convert that into 7942 text, which is a wiki text? I don't know, but we will work with the chairs and get the necessary feedback. so that we can do one way or another. Yeah.
Okay, thank you. Makes sense.
Thank you so much.
Okay, then it's the
You'll
last
have
15
fallen-
minutes for Randy to drive it home.
You'll have fallen off the end of the deck.
Oops, that's okay. Voila.
There we go. Okay, Randy Bush, ARCIS and IIJ Research. Next slide. Let's remember the primary goal here is discovery of layer 3 IP topology and liveness to support LSVR's SPF. Next. Just a silly picture you've seen too many times. Let's remember the dark rectangle is layer 2. Okay, and we're trading Ether PDUs between devices and pushing northbound to BGP SPF so it can take the interlink state and turn it into a more global topology. Next, please. This is not a routing protocol. Okay, we just discover the link, not what is beyond it. Okay, we leave that to BGP up northbound. But let's remember we are at layer 2 because we're discovering layer 3 addressing. Next slide, please. So people have many times said, why don't we just use TCP? It's because we don't have IP addresses. So on the north side of this slide, we see a transmission protocol, okay, that assembles Ethernet frames into PDUs. And then at the bottom, we have PDUs by PDU type, payload length, et cetera, et cetera. And we're going to, the meat of the protocols in the PDUs, but there is this transport thing, so you can use Ethernet frames and using transport at layer 2, get large PDUs. Because of this new transport, next slide please, we begged the Transport Directorate to do an early review. And Jorg did a great review, in fact, multiple times, and it was really quite good. And so that took version 4 of the draft to version 5. Next slide, please. Of course, you've read the draft, but if you had, why did you not report the bugs that Rob reported to me yesterday? So there's now version 6 published yesterday that cleaned up typos and some mistakes in the diagram of the transport header, but they were just field mistakes. Okay, so next slide. 06 was published. No significant changes. Next slide, please. We have 2 implementations, one in Python 3, which is not an implementation of LSDL. It's of its predecessor, LSOE. It is open source in Python 3. There's an L3DL implementation in Golang. Within ARCIS, it is not open source. And that's the end of the L3DL preso. If anybody has questions, please feel free to interrupt me at any time. Next slide, please. As Gunther said, you're not going to get this thing past the IETF without security. So we have some simple security available on this of 2 flavors. Next slide, please. In the open PDU, we added auth type, what kind of security it is, and the length of the key. And then because it's a PDU, we sign it with the signature type, the signature length, and the signature. It's really stupid stuff, but provides a fair bit. Next key, please. Next slide, please. Sorry. The key in the open PDU is a public key of an asymmetric key pair. The sender has the private key, of course, and doesn't give it to anybody else. So the device sending the open might use one key for all links, a different key for each link, or some aggregations thereof we're not saying. Next slide, please. There are two general verifications. One is TOFU, trust on first use. The open key is generated on the sending device. The receiver just believes it. It uses it to verify all subsequent PDUs from the same sender. So it's trust on first use. The open gives the receiver, says, this is my key, and the receiver blindly believes it. And this is horribly common in security. It's not the best, but it's not bad. Next slide, please. What you can do instead is have a PKI, okay, a key infrastructure, so that the sender generates their public-private key pair, but then goes to some public server, that private key server, that, for instance, is in the data center and handles all keying registrations, and it enrolls the public key. So the key server signs the public key and provides a trust anchor. Then the relying party can check that the key server in fact signed the key and it has verification. Next slide, please. Don't worry. Next slide. This is not X509. Okay, you don't need all the fancy for certificate stuff. You just need to wrap the private key, the public key, in a signature of the server. Okay. The only additional thing you have to do above TOFU as a receiver is to burn the central key server's trust anchor in all the receivers so that they can check that the signature around the sender's public key is in fact signed by the trust anchor. Next slide. In either case, TOFU or anchored trust, their verification's the same. The key that was provided in the open PU verifies the signature, which was done by the private keys, from the sender. The only difference is that the PPKI-based keys can be verified against the trust anchor at open time. You just check the signature on every message. Next slide. The choice of which keying method to use is left to the operator, in the sense that your data center can use a trust anchor or might use TOFU. That's your choice. You could probably even subdivide it by pods or something, but now you're getting kinky. Okay, and it's going to be operationally annoying. Next slide, please. Since nobody reads anything before WG last call, I think we requested it, but it's not actually in last call, or at least Data Tracker doesn't know about it. If you have any comment, Gunther, feel free.
Yeah, it's hard to do working group last call before working group adoption.
Well, we adopted it a fair while ago.
2 months or so, yeah.
Yeah.
I'd love to have a question with you with John when you guys are ready.
Yeah, go on, Victor.
John?
Is it time for me to talk? I guess so. This is John Scudder. Hi, Randy. So I confess this is my first exposure to this particular draft. I did just skim it. One thing that I bump into every time anything involving keying and security comes up is somebody in the security directorate asks, what's your mandatory to implement algorithm? Do you have one? I didn't see one.
There is currently not one. This is being discussed. We have
Okay.
somebody, we have a secret co-conspirator on the security director.
Good. It always helps. All right, thanks.
You know him well.
All right.
Okay, next slide, please. So we wanted to augment and extend the protocol by being able to discover the BGP attributes of a neighbor. Next slide, please. So we now have this draft describes a PDU, which again is exchanged at layer 2 as part of L3DL, which says, hey, there's an upper layer protocol, typically a routing protocol like BGP, which has the following attributes. And there's an arbitrary number of attributes with an attribute list. The ULPC type says, hey, this is BGP, for instance, and that's what we really care about. Next slide, please. The point is to provide the absolute minimal set of configuration parameters for the open to succeed. Next slide, please, because we don't want to replace or conflict with the rather extensive data exchanged during open. If you have, next slide, 2 sources of truth, it's a recipe for complexity and pain. So therefore, we exchange the minimal, next slide, the minimal data to just get the open going so all the rest of the GORP can be exchanged. What do you need to get BGP going? Next slide, please. 3 things. Your neighbors, you have to exchange your ASNs. You need what address you're going to have for peering, and the BGP authentication data, for instance, the MD5 hash, if you're going to use it. I had to describe on list that the BGP peering address may or may not be the direct address on the link. It can be loopbacks. And how you detect that or signal it was a matter of some discussion, and possibly it should be incorporated. I think I actually incorporated it in the latest version of the draft. Next slide, please. Yes, of course, there's an IPv6 version. Next slide. Similarly, we requested WG last call, but it ain't happening yet. That's okay. And that's the movie end. 2 minutes for questions.
Thank you, Randy. No questions? So for the security draft here, has there been like any discussions then also with the security working groups and so onwards?
As I said, there's a security person who's secretly helping with the draft.
Okay.
It's Russ Housley.
Yeah, no, yeah. I'm just trying to figure out how to get, if there is feedback and so onwards, to have some tracking awareness of that, on the working group, email list.
He didn't want to be listed.
Okay.
There's a Jacob's in the queue.
Rainey's Jacob from Oracle Cloud again. So you mentioned that there's 2 implementations going. The first one is the older LSOE that's been open sourced in Python 3. Is there plans to update that, or is it just if somebody's interested, it can be updated.
Gladly work with somebody updating it. The senior software engineer who wrote it is a little overoccupied at the moment within Arcus. So
Understood.
he's here, he can speak for himself, but he's choosing not to. So I think we can take that as a signal.
Okay, and point of clarification, you mentioned with the trust model that if we use a PKI-based approach, the CA that is used can be public or private so long as the device actually trusts the CA itself, correct?
Right.
It's going to be doing the signing.
Yeah.
Doesn't need to be public.
No. Well, it needs to be
Trusted.
within the scope, reachable scope of the devices trusting it. You don't actually have to go to the TA on receiving. You don't even have to go to the TA on the open if you have burned the TA's public certificate in the receiving device, because the receiving device then has the TA certificate and can just use it to verify the encapsulated private public key of the sender. So you don't even have to be able to reach the PKI if you've got the PKI's public certificate burned in the receiving device. If you don't, then the receiving device is going to have to go find the PKI CA and say, hey, give me the wrapper here, please.
Got it. Thank you.
Sure.
I think, yeah, thank you. So we're at the top of the hour right now. I've seen other sessions where there was like a hard cut. It's probably not so hard as such, but I think we will have to stop the discussion at this point in time now. Okay. Thank you, everybody, and see you in again, or probably virtually in about 3 months from now.
All right. Thank you.